Okay, let's discuss this, guys. About so there is one small topic which we have to discuss in the terraform. That is, you know, so the handling the state file. It's basically, if you remember, when you do apply, right? Terraform apply. What does it do is will just provide an infrastructure. It will provide an infrastructure, meaning it will create an infrastructure and store the information of the what it has created, what kind of resource it is, what is an ID, everything will be recorded. That recorded in a file. That file is nothing but the state file. State is nothing but the information which has currently or the holding information. Okay, the present status of the resource will be maintained in the state file. That is the main purpose of the state file here. Let me show you how it evolves from state file. Okay, I think this could be now. I'll show you the basic one. Right. If you see here, there are a couple of things which we have discussed. I mean, like Terraform init, Terraform plan, Terraform apply, Terraform destroy. I mean, it's not necessary to destroy, but these are three mandatory things you have to be provided. Okay. So now the point is, if you see here, when what does it happen when you do init is, it will initialize all the related provider, which is like installing all the libraries or all the necessary modules or all the providers it is required. For example, in your main.tf, if you define a provider called AWS or local file or GCP or VM related information or any of the things, right? That will be downloaded into your Terraform modules, Terraform folder. Okay, that is what will happen when you do init. Next one is Terraform plan. See, in the Terraform plan, what does it do is it will just show you, hey, I'm going to create this infrastructure. Are you okay or not? So now let's walk through the same thing here. See, when you do there is a main.tf file or it could be a tf file. When you do plan, right, Terraform will do two things. Okay. One thing is check the provider, and then at the same time, it will check the plan with the one of the tf state file. Meaning two things. One is providing a plan and then checking the status of the Terraform, which is nothing but the check plan. What does it mean is, if you remember, okay, let me show you here itself. I do have 104 here. Okay. Okay. Here, what does mean is, what I'm gonna do is I'm gonna remove this already a file which already created by a Terraform, and then I'm trying to do a plan. See here, when you do Terraform plan, what does it happening is, if you based on this architecture diagram, it is trying two things. One is providing you a plan which is in the form of output. As a result, as an as an outcome, you are going to get the plan information, as well as internally it is checking the plan with the tf state file, and then based on that information it is displaying you the output. What does it mean here is that when you, if you, where is this? Okay, so initially internally it is checking tf start, if you see here the first statement, refreshing the state, meaning it is checking, am I already created any of the file, or is it there, what is the status of it if it is presented, and it's finding everything from a one file. That is, file is nothing but a tf state file. Okay, based on that information it is generating the plan. Now based on this it is telling, I'm gonna create it, because the tf state file contains information about whether the, I mean, basically the tf, I mean, main.tf is intentionally doing a creating a file. That is the main functionality of the main.tf, which we have written few days back. Now whenever I remove this file, right, that information is been handling by the transform, I mean, terraform.tf state file. So whenever I removed it, Terraform state file automatically got updated. Okay, there is no file tf underscore node.tx. It stores that information. Okay, so if you see here, before removing this tf node.tx, it is saying there is no plan, because it is telling, hey, you already want to create a tf.node.txt, right? So it's already presented. There is no plan which I can provide you, because the file is already existed. So what I've done is I intentionally removed this .txt, and whenever I removed tf, terraform.tf state file is observing this particular resource, and then what is happening is it is updated its own information. Okay, someone has removed, so there is no resources and all. There is no resources at all. That is what it is found, and then updated this tf start state file, and then finally it is saying, okay, since there is no resource of a file which is tf underscore nodes.tx, so I have to give a plan to create a that particular resource. Okay, and the plan is, okay, one creation, that is what, one to add. Creation means adding. Okay, what to add? One local file. What are the properties? Yes, the file name should be tf underscore node.tx, the content should be this one, and all the properties will be applied by automatically by this resource. So when you apply, so this is what I'm going to provide you a plan. Okay, see, if now you have to focus on here two things. When you do apply, right, are you able to see my screen? I mean, I have shared two things here. Okay, right. Okay, this one I'm talking about, the architecture diagram here. Okay, so when you do terraform plan, first it will go to check the tf state file, and then find the information, and then provide you an output. tf state file contains the information about the resource which you have created it. Okay, so that holds the information about that particular terraform file, I mean, that particular resource. Now we have taken example of the local file itself. Same behavior works or apply for the aws resources also. Everything depends on the tf state file. If tf state file does not exist, what does it do is it will create it and then find store the information. If you remove it, For example, now in case if we remove the tf state file, what does it do is it will find and then it will think that okay, there is no resources at all, I'm gonna create it. So that is what it will do. This is the way how it will work it. Now let me do one thing here. Now let me open a terraform state.py file. Okay, see this. Now this is the state file, how it looks. Okay, and one more thing which I forgot to tell you is, in this process, the tf state file will be in locked state. Locked state means, for example, someone is also trying to create a same resource or trying to utilize the same terraform file. For example, you would be working in a distributed environment, right? And then you are storing in one of the source code management tool, right? So based on that, you would be also knowing about uh, someone has already tried to pull the code and then he's also trying to execute the same thing. So at that time, what will happen is terraform state file will be in locked state. So this way, one people only will be executing the terraform at one time, so no other resources will be interacting with this state file, so it won't be disturbed. So it will be in locked state, so no one will be disturbed. It is exactly like in a Java or some basic computer science. There is a concept like lock system, process lock, meaning whenever a cpu utilized for one process, the process will be locked by the uh, particular process id, right? It won't be shareable by others. Similar way, whenever someone is working, whenever someone is applying the plan, terraform state will be locked state and no other resources will be shared of this terraform state file. So the same thing will happen here. Okay, so the Terraform, let's see now, Terraform state file contains an information in the JSON format here. Okay, you have to remember one thing, guys. JSON is a different format, the Terraform which we have written in the HCL format. Okay, HashiCorp language format. You have to understand these two things. Terraform state file will be in the JSON format, which is a JavaScript object notation, and everyone will be easily understand of it. Okay. Now, if you see here, based on the Terraform, based on the operations that we have done, which is main.tf we have, right? So that is, what does it doing? It is just creating a file in the local machine. That's it, nothing else, right? Similarly, if we return some of the functionality to create an infrastructure in AWS, the Terraform state file have a different functionality. It will have a different definition. Definition means the content. Let's see the example here. It contains what Terraform version we are using. It contains what outputs are you going to present, and what I'll do is, do I have already information about it? No. Okay, I'll just do one thing. I'll open a main.tf first, and then we'll come. In the main.tf, we are just we are just importing the provider, and then we are using a resource called local file. In this local file, we are providing a properties like a file name and a content. That's it. And obviously we are printing a one output. This is what we have done it. Now let's see what is the Terraform state contains, which has created after Terraform plan. Okay, now when you do Terraform plan, it automatically created TF state file. That TF state file created all the information related, what version of the Terraform you have used, what is an output are you printing from the main.tf, and what resources it is going to create. Okay, so here if you see here, managed mode. there are some other modes like auto mode, which will be created automatically by the terraform, not to by the user here. Okay, and what type of resource you are using? Local file. If you have used some other resource like AWS instance, some other thing, right? So you would be getting a different type of resource name here, and the name of your resource is my file. And for this it is going to use what provider? The provider from the HashiCorp. The HashiCorp registry URL is registry.terraform.io slash HashiCorp slash local. So this is where the provider has been downloaded. Okay, now, and it is going to create all the information about, where is this? Okay, all the instance details, meaning when you do in, I mean, of course you might have think about, sir, we did not created a instance, but how this instances is coming. So by default terraform state file contains instance, means on particular time. This will be there by default even for the local file operations or AWS EC2 creation files or anything. This will be there for default. Okay, and now this contains some of the attributes. The attributes is nothing but a properties of the file. File has these many properties, like what is the source, what is the file name, what is the file permission, directory permission, and the SHA, MD5. These are the security codes, unique codes. So these are all properties of the file. This finds everything in the state file here. Now let's example, I mean, let's see the AWS TF state file. So yeah, what I've done is yesterday, I mean, in a few days back, we have created AWS resources, right? In the AWS resources, we have launched the EC2 instance, correct? So that EC2 instance has also one of the Terraform state file when you do plan it. Now let's try and understand TF state file here. We have destroyed everything. If you remember last time, we have destroyed. uh, that's why it does not contain anything. Okay, so if we don't destroy that information, I mean, terraform state file contains all the information here. Okay, now let me do one thing. Yeah, this is a good example. There is a similarly like a TF state file is been there, right? For every TF state file, there is a one backup file will be get created. This is what that is. Meaning, let me put it this way. For example, first time you are planning it, and if it is not created, I mean, if does not have a TF state file, it will create it and store it. This is the first time. And second time, what you have done is, whenever, I mean, before the second time, the first time itself only, whenever successfully TF state file got created, it will automatically create another backup file with the name of terraform tf state.backup file. In the first phase, I mean, in the first apply, these two files are identical. For example, if you do the second time, what you do changes in the second time. For example, you have added one more file to create it. When you do, you just change the main.tf saying that, okay, I want to create a second file also. You have added a code for that. That is the change that you want to do it in the second time. Now you have done a code changes, and now you do terraform plan. What does it do is, it will go and check the tf state file, and tf state file has one information saying that one file is already exists. I'm going to create a second file. This is what it is going to create, because you have changed the code in the main.tf to add a second file. Before changing the plan or in the second time, what does it do is, it will take the backup of the first version of the tf state file. So then if it makes sure like the backup file is already existed, it will make sure the tf state file will change to the second changes. Then in the second changes, the tf state file is being executed. Okay, so meaning for every plan, it is going to check with the TF state file and it will operate it, and then it will take the backup also. Now in this case, if you see here, the last operation that we have done is a, for this AWS example, is a terraform destroy. Okay, when it is going to destroy, it has taken a backup. That backup contains the previous state of the destroy. I mean, before doing a destroy command, what exactly the status. If you see here, you will get to know it contains a 3 EC2 instances. Okay. See, we have used Terraform version 1.5, and one of the total resources are these, and mode is this. Mode is managed mode, which is by the terraform itself, and the type is you have going to create a resource type is the AWS instance. The instance names are my EC2, and that is provided by the HashiCorp. If you see the instance details here, attributes like what is the AMI ID you have used, what is the ARN ID, this is instance ID, what information, how many CPUs it has been using, what type, it is a T2 micro, T2 medium. It's find everything. What is the EBS volume? What is the host ID? What is the security group for that particular instance? And everything it is storing in the information itself. Okay. Now, similarly, if you go to this is a public IP, this is a public DNS name, and everything it's storing it. Okay. Now, let's see the second one. Second IP, I mean, second EC2 instance ID is this, and the CPU configuration is this, and where is the public IP? Yeah, where is the public? Yeah, this is the public IP of the second EC2 instance. Public DNS of the second instance is this. It stores every information in the Terraform state file itself. Before updating the Terraform state file, it is going to take the backup. That backup is nothing but a Terraform state file. So like this, it will. So meaning, what does it mean is, the terraform contains a last two previous states information. That's it. Nothing would be there here. So this is what I want you to discuss about the terraform state file. This is an important also. So we have to be very careful when we are handling with the terraform state file. We shouldn't do remove also here. So some people will be storing this state file in the remote means either in some of the S3 bucket or some of the source code management tool itself. They will be storing that information. Nothing about particular any restrictions, but still have to store it on the safer side. Yeah, any questions, guys? So this is what I want to discuss about the terraform. And by this now we have been talked about the terraform, all the modules whatever we have mentioned here. Okay, any questions on this? Kiran, Kaushik, I think Kaushik has been okay, fine. Let me know if you guys have a question so we can also discuss about it. But the thing is, I would suggest you, when you are writing a code, right, go with the very basic one. Make sure one main.tf, in the main.tf you just include your provider and then resource. That's it. Then later on improve one by one. Try to add one by. So this way you will feel comfortable and then easy to understand. Don't go with the a bigger script like I have shown you the yesterday one example, right? Terraform GitHub examples. Don't go directly with that. Start writing your own. Don't choose, I mean, don't do directly copy paste. What you do is, with your hands, type all each and every keyword of each and every line. This way you will remember the syntax also. This will help you when you are attending an interview. If someone asks you the syntax, you will easily able to write, or you will easily able to tell it. This would help you. That's why I'm suggesting you start with a very basic one. Okay. Yeah, Kaushik, you are saying something. Any questions, Kiran? But I would suggest you go with that and then see. Okay,
Sure. Yeah. Thanks for that.
right. Now we will start with the Ansible, which is nothing but a configuration management tool. What we do is we will be installing the Ansible, and we will be talking about a couple of other parallel tools for the configuration management tool. So generally, now let me explain you the what are the configuration management tools are being presented in the DevOps. So along with Ansible, we do have also Puppet, Chef, Salt Stack. So these are all some of the parallel means right, a configuration management tool you would be doing it here. Okay. See here. Along with Ansible, there are some of the tools like Puppet, Chef, Salt Stack, Rack HD, Cobbler, Vagrant. Vagrant is specifically for managing the virtual boxes. Like we do use a Docker Compose, right? Similarly, Vagrant will create a file and then to spin up a multiple VMs in itself. So I think it may not come under the configuration. I mean, it may come under the configuration management, but not for an application based, for the VM based. Okay, that's it. And earlier, before Ansible comes into picture, Chef and Puppet are the main key role playing in the configuration management in the DevOps area. So now it has been upgraded. A lot of people has already been used Puppet, but they started also using Ansible. Why? Because the Puppet. I mean, these are very hectic kind of thing. Hectic in the sense the way how you write is not a declarative. The way how it will be, it is not in a declarative model. You have to learn a different syntax over together. But in case of an Ansible, right, it will be somewhat easier than the Puppet or Chef. It is because it will be in the YAML format, H2 another markup language, which is human readable, understandable format. It does not have much syntax issues. I'll show you things. I want to show one more thing. Ansible you will write in a YAML format. Okay. So till now we have written the Terraform in the HCL language, which is a HashiCorp language, which is the syntax is a different. Now we will be writing in a YAML format here. Okay. Declarative. Here, I'll tell you some differences with the Terraform and Ansible, so you will easily understand one thing here. Yeah, here. I want you to talk about the some major difference between the Terraform and Ansible here. You would be writing the code in Terraform as HCL, but in case of Ansible is YAML format. Okay, YAML is added to another markup language, meaning I'll show you YAML syntax. First, you will be starting with the three dots. I mean, three hyphen symbols, which means, okay, this file is a YAML file. That is what an index. If you remembered, if you are writing a shell script, right, you would define a shebang line, right? Similarly, here also we will be writing a three dots or three hyphens, which means, okay, this file is in the YAML format. Okay, that is what it is meant. So the list of, I mean, first you would be defining a list, which means hyphens. If you want to define a list, you have to define a hyphen hyphen. That's it. If you want to define, for example, if you want to define some properties of this particular list item, you don't write it in the same line. You just give a tab or one space and then you define. For example, let me put it this way. Okay, now I have defined a list. Now I want to define some properties of a apple. I just give a tab, or I can give here itself color red, taste. I mean, I'm just defining some properties here. Sweet, place, place of birth, cold areas. So like this, I have a property. Now, if I want to define another item of this, orange, same properties, color, orange color, taste, sweet and sour, right? I mean, yeah, something like this. So similarly, first you have to define a resource, or you want to define a tasks like this. My tasks has a list. First name is install Apache server. For this, what you do is apt package manager. Apache. Something you define something like this. So this is basically the syntax. First you define a list. A list contains the properties. That this is what you just need to remember here. Okay, see here, similarly, see here, he has defined a one employee. One employee name is Martin developer, job is a developer, and skill is a elite. So if you want a list of employees, he's just define first employee and his properties, and second employee and its properties. So this is how it will be formatted in the internally, which is like an array or an object. Okay, so this is a syntax of a YAML format. Just you would be defining a list. Under the list, you would be defining a tasks. That's it, guys. Why I have mentioned here is that is the major difference, YAML and HCL. Okay, in a HCL we just define a resource, the resource type, and then resource name, and then its properties. But here, first is the the resource name, which means a list, not like resource, the list item, and the properties of the list item. That's it. Okay, so just a minute, guys. Just a minute. Okay, next one is procedural and declarative. Here in HCL, if you want to install, or if you want to create any infrastructure, first thing is you would be writing a code which is in a declarative format. Like, okay, I want to create a EC2 instance and these are the properties. You are just declaring it. But in case of a Ansible, you would be doing everything like a procedural language. If you see here, while we are learning a terraform, I have drawn a one horizontal, one is a imperative and another one is a declarative model. Now a terraform is in between imperative and declarative. But now procedural is, Ansible is completely procedural, which is in completely in left hand. You have to specify each and everything. Okay, you can't tell, okay, I want install a Apache EC2. I want to install a Apache. That's it. You can't tell like that. You have to tell a couple of other information. Okay, if you want me install Apache in your Linux machine, what package manager should I use? And what state you want me to do it? And what are the permissions? So everything you have to mention, which is a procedural. You are going to tell a procedure saying that, okay, first use apt package manager, then you install it, then this is the configuration. I'll show you an example of and full install Apache. See, see here. Okay, first he defined three lines, and then he defined a one list item. The list item is a name. What that is name of the particular task is, HTTP is there or not. And host is nothing but a in which mission, Linux mission. Here he is just telling, okay, in this mission, there is a task. The task name is ensure HTTPD is installed. HTTPD is one of the lightweight web server in a Linux mission. Okay, and for that, use a module called M. And while using an M module, make sure HTTP a state is present or latest. Latest means it will make sure the latest version has been installed. So this is like a procedure. You are telling a procedure. First, use this host and then use a M module, and then using a M module and check a one service called HTTPD, and that particular HTTP service state should be latest. Then it will make sure HTTP state should be presented properly. I mean, installed properly with the latest version. This is all a different thing. I mean, same version, but we don't go directly here. Okay, so any questions, guys? So this is a simple what does it mean about the procedural here. Here another one is default approach, mutable infrastructure and immutable infrastructure. Meaning, once Terraform created an infrastructure, it will automatically, I mean, it will automatically show the entire information about the create and destroy information, meaning it can destroy also. But in case of Ansible, it cannot destroy the infrastructure. Immutable means it cannot be changeable. Once it's created, it can be done. That's it. It can't be changed anything. Okay. Lifecycle management means Terraform has a Terraform init, plan, apply, destroy, right? Here we will just use the Ansible playbook or Ansible apply. I mean Ansible run. That's it. It does not have a multiple phases like Terraform, init, plan, and apply. It has only simple Ansible and task name or ad hoc commands. That's it. It won't have a multiple stages. Okay. And provisioning and configuring is the same. I mean, Terraform can create an infrastructure and then do install a particular software. And Ansible is also can able to create infrastructure and then configure the things. This is not much difference in terms of the capabilities. Okay. And now I want you to install. What I'm gonna do is then we will explain the architecture in some other time. But first, make sure you have an installation of a Ansible. So you can directly go to the official documentation, or you can go with the anything. Is fine here. First update, then after update, you install the software properties which are in common. You major thing is it should have a Python to be installed as a prerequisite. Okay. Now you are just adding this repository of the Ansible to your repositories list. Once that is done, you would be and then install Ansible. So if you see here, all the Python, I mean all the Ansible related, it is completely based on the Python 3, meaning the prerequisite of Ansible installation is a Python. Okay, if you don't have a Python, it may not work also. Even if it does not, it is downloading the default Python libraries related to the Ansible. If you see here, Ansible core, which contains Ansible modules, Python related help related and everything. Okay, so 285 MB, it is getting downloaded. It is extracting each and every package. Okay, so you can directly install using this command, or even I would also suggest you can also follow the DigitalOcean because they have a prominent steps also how to install their things. But it's pretty much good here. Okay, yeah, let's do one thing here. Yeah. So we have just installed configuring the Ansible also we can do, but what I can tell you is uh, yeah, this is what we have to tell it. But before telling this, we want to go through the architecture diagram that would help you to understand this configuration also. I mean, in the host list, you are going to mention how many missions you are going to handle. That's it. See, simple. In this example, he has given a host of 3 missions. So that's why he has mentioned it here. We will be talking architecture in next class, which is an early morning as usual regular. But if I start here, you would be getting confused. First, I'll better and create a walk through the architecture diagram. Then we'll come to the host file. You will easily understand basically. Yeah. Yeah, okay, that's it for today, guys. Just I have shown you how to install Ansible. That's it for today. And tomorrow, what we do is we will walk through the Ansible architecture diagram, how it will work, and what is the major point or major benefit for the Ansible, which is like automation part of configuration and a lot of stuff. Okay, so that's it. We will discuss it tomorrow. That's it for today. Thank you, guys. As usual, tomorrow 7:30 a.m. only.
Okay.